Hello, friends. You are on the Galactic Express channel.
And of course, liquid water is what makes life possible on Earth. So scientists who make it their business to quest for extraterrestrial life are keenly focused on the study of Europa. But how could liquid water, which freezes at temperatures below 32 degrees Fahrenheit, exist on a moon 5 times as far away from the Sun as the Earth? Europa orbits Jupiter in an elliptical pattern. Sometimes it's close to Jupiter, and sometimes it's farther away.
When it's close to Jupiter, it gets stretched by Jupiter's gravity. But it's an effect that we call tides. When it gets further away, it's stretched less. So it means that the body of Europa is continually worked.
Friction caused by this stretching generates heat, just as a rubber ball heats up when it's squeezed repeatedly. At the planetary scale, this process is called tidal heating, and it creates enough heat, possibly, to keep H2O miles below the surface of Europa in liquid form. It also appears that this stretching causes fractures in the Jovian moon's icy crust.
Imagine if you were trying to change the shape of an egg. What would happen to the shell? The shell would crack. And so when we look at the surface of Europa, we see lines all over the place, which are most certainly marking the locations of cracks.
The cracks appear to open and close frequently, and the potential for these cracks to allow subsurface water to interact with the surface has important implications for the possibility of life on Europa.
Water from the ocean is going to rush up into the crack. When it rushes up, it's going to freeze, start to freeze. A few hours later, when the crack closes, it's going to squeeze that slush up to the surface. And so wherever we see these lines, there are double ridges, one ridge lining along each side of the crack.
Most of the water, no doubt, sloshes back down out of the crack to the ocean below. It's likely to carry with it some of the building blocks for life that have seeped down from the surface. The top of Europa's ice layer holds oxygen. It's been separated from the H2O in the ice by charged particles in Jupiter's magnetic field.
In addition, the surface of Europa likely has organic compounds that come down from comets and bits of comets. So again, the surface has another ingredient that's important for life.
Dr. Richard Greenberg of the University of Arizona has graphically depicted how potential life forms might take advantage of the ecosystem created by a crack in Europa's icy crust.
Although the outer few inches would not be a good place for life to live because of radiation, once you go down just a few feet, life would be safe from radiation and also would get enough sunlight for photosynthesis. So you could have an organism at that level that photosynthesizes, and it would be connected to the ocean by this tidal water that rushes up and down every day.
A day on Europa is much longer than a day on Earth, about 3.5 times the length of an Earth day. Time for mobile organisms to venture into the fissure.
You could imagine other organisms that grasp onto the walls of these cracks and just exploit the flow of ocean water coming past them every day.
Even mollusk-like or jellyfish-like creatures might rise with the water into the cracks to take in fresh nutrients from the surface. Life in Europa's ice-covered oceans may also draw energy and nutrients from a place other than the icy surface. It's possible that residual heat at Europa's core has resulted in deep-sea hydrothermal vents. On Earth, such vents host multiple forms of exotic life.
What happens is that reducing water that's very hot and has lots of heavy metals comes out through the groundwater and is injected into the ocean itself. And there's a huge gradient in the chemical composition that life can feed off of. This chemical source of energy allows huge populations of bacteria and other very small life forms to exist. And there's a whole ecosystem, a whole food chain on top of that, leading up to fish and various worms that thrives at those locations.
In recent years, talk has arisen of sending a lander to Europa that could penetrate the ice and probe for life. But Europa expert Richard Greenberg believes that a lander might uncover signs of life without penetrating the ice.
If we send spacecraft to Europa to look for life, it might be pretty easy to find it, easier than people have realized. Most planning has considered, how do we get through these miles of ice to get down to the ocean? How do you drill through or melt your way through? It may not be necessary. If you can land in a place where liquid or ice has come up from the ocean recently, you might find signs of organisms in that ice. Or if you land really smart and find an active place, you might actually be able to sample real fresh oceanic water.
The risk in that case, some feel, would be contaminating the icy moon.
If we had microorganisms that stowed away on a spacecraft that landed on the surface of Europa, and those microorganisms found their way into the liquid water of Europa, we might later discover life on Europa that was life that we had sent there.
But elsewhere in our solar system, on another distant moon, earthly contamination isn't a danger. Life here would simply be too exotic.